So in this video, what I'll be doing is solving some questions about concentrations of mixtures. For example, here, if you notice, what we're doing is we're trying to mix two different solutions that have the same anion. We got copper nitrate in one of them, and we've got zinc nitrate in the other one. And they want the final concentration of nitrate ions. So the math would work out. In my head, I'm planning, well, what I'll do is I'll find the number of moles of both copper nitrate, and then I'll find the moles of zinc nitrate. And then using that, what I'll do is I'll find the moles of nitrate ions total. And those nitrate ions and the total volume will help me solve for the total concentration. That's what I'm saying. So basically, step one, these are the knowns. Then the ratios say we get the moles of the unknowns and then the concentration. So step one, we'll have two sets of knowns to find. The first one being copper nitrate. So let's do that for copper nitrate. Again, I'm doing step one first, right? So this is step one. So if I do copper nitrate, the number of moles of concentration into volume, concentration is 0.25, volume is 50 over 1,000. I get what? 0.0125 moles. Then I'll find the number of moles of zinc nitrate. That is, concentration for zinc is 0.275 into 80 over 1,000. That is 0.275 into 80 over 1,000. That is 0.022 moles. Those are the moles of both of my knowns. And using that, both of them supply moles to my unknown. So now the step two would also have two parts to it. The known, the first known to my unknown, since you must realize that copper nitrate, when it dissolves, will give me 2 moles of nitrate ions. That's the ratio. So the ratio coefficient is 1:2. So the number of moles of copper was 0.125. And so the moles of nitrate through the copper would be twice as many, 0.025 moles. Now when I know that, even zinc nitrate, when it dissolves, gives me 2 moles of nitrate ions. Yeah? So when I do the zinc nitrate to nitrate ratio as the known and unknown ratio for there, it is also 1:2. And the zinc's moles are 0.22. And so the nitrate moles from zinc would be twice as many, 0.044. Again, cross multiply. So now I've got the moles of nitrate from both parties. But then what is the total moles of nitrates from both parties? So the total moles of nitrate would be 0.025 moles from the first one and 0.044 from the second one, which gives me 0.069 moles from the process. Now I go to my step 3. That I'll use just simply number of moles is equal to concentration into volume. The total moles of nitrate are 0.069, and the total volume when I mix both solutions, that's what I go upstairs to see. What is the total volume of solution? Well, I mixed 50 cm cube with 80 cm cube. So my solvent is 130 cm cube. So that. And then I find the concentration, if that you understand that. So what does that work out? Let me get a calculator. That's 0.069 into 1,000 divided by 130. 0.53076, 5308 or 531 moles per dm cube.